All right. We have now question 1.1. Within question 1.1, the question says solve for x. Now, in the previous videos, we did question 1.1.1 and question 1.1 through question 1.1.3. Now we're going to do question 1.1.4. I'm going to write here 1.1.4. If you don't see the question clearly, it is 3 to the power of x plus 3 minus 3 to the power of x plus 2 and equal to 486. We're still going to find x. All right. Let's solve the question. I'm going to write the question. Let's start solving the question here. X plus 3 minus 3x plus 2 equal to 486. Now, what can we do here? We can break down these exponential equations, excuse me, terms. I meant to say terms. We can break them down to, like, I can write 3 to the power of x times, I prefer to start with, okay, let's just write 3 to the power of x times 3 to the power of 3 minus 3 to the power of x times 3 to the power of 2 equal to 486. I'm going to write here 486. Okay, now, why am I doing that? Because we do know this property that is a to the power of m plus n is equivalent to a to the power of m times a to the power of n. Okay, so when we have base like this with an addition or subtraction in the exponent, we can break them down. Now, why am I doing that? Because by doing so, we notice we have like 3 to the power of x as the common factor. It's common between these two terms, so we can take 3 to the power of x as a common factor. So we can write 3 to the power of x as a common factor. Over here, we will have like 3 to the power of 3 minus 3 to the power of 2 equal to 486. And then 3 to the power of 3 is 27 minus 9 times 3 to the power of x equal to 486. Okay? Now, all this makes 18 times 3 to the power of x equal to 486. Now, it's a product here, so we can solve if we divide both terms by 18, both sides of the equation by 18. Sorry. About that. No worry, you're watching the video, so you want to, it's not contagious. Okay. Over 18, we divide both sides by 18. Now I'm going to do here 486 over 18. So this is equal to 27. Now you notice that when we divide by 18 cancels out, and then I'm left with 3 to the power of x equal to 27. Now we can write 27 in terms of its prime factors. By doing so, 27 will become 3 to the power of 3. Okay. If you're unsure, do write 27 press equal shift and then fact. You see that 27 is equal to 3 to the power of 3. Now, the reason why I'm writing this because there's a property that says when you have like a to the m equal to a to the n, this implies that m equal n. Okay. In this situation, we just drop the basis and then we equate the exponents. So this means x is equal to 3. It's the solution. Thank you. Alternatively, we can also solve the same problem. You see, okay, I'm gonna write it here. Okay, because it was 3 to the x plus 3 minus 3 to the x plus 2 excuse me, equal to 486. The fact that the basis is 3 and then the exponent is x plus 3 and x plus 2, we can take the highest common factor this way. We can write 3 to the x plus 2 times 3 to the x. Okay? No, not to the x, but 3 times 3 to the power of 1 minus 3 to the x plus 2 equal to 486. Okay. Why? Because of the same reason as before, as over here. We can break down this into this one into 3 to the x plus 2 times 3 to the 1, because if you combine the two, it's gonna be okay. Let me write here. It's like I'm gonna add one more step. So I'm gonna move these ones down a little bit. For better understanding, let me just redo the previous slide. This can be written as 3 to the x plus 2 plus 1. Okay, we do know this is equal to x to the power of, this is going to be 3 to the power of x plus 3 minus 3 to the x plus 2 equal to 486. Now, of course, this part, as I said, this is just 3. Okay, but I prefer to write x to the power of, I prefer to write x plus 2 plus 1. Now, we can break it down by saying this is 3 to the x plus 2 times 3 to the 1 minus 3 to the x plus 2 equal to 486. Are we together? Suppose. Now, you notice that this is the common factor between these two terms. We can take it out as a common factor. So we like 3 to the power of 1 minus 1, and then 3 to the power of, and then 3 to the power of x plus 2 as the common factor, okay? Equal to 486. Now this will just make 2 times 3 to the power of x plus 2 equal to 486. Now we can divide both equations by 2. I mean, both sides of the equation by 2, not the two equations. That makes 3x plus 2 equal to 243. And then x plus 2 equal to 243 in terms of its prime factor. This is equal to 3 to the power of 5. If you're unsure, you can do the same way. You write 243, you press equal, and then shift, and then fact, the button fact. So you see, I'll do it over. You write 243, and then you press equal, and then you press the shift button, and then you press the fact button. You got 3 to the power of 5. Now, applying then this property will cause us to drop down the basis and then equate the exponents x plus 2 equal to 5. And then that makes x is equal to 5 minus 2, which means x is equal to 3. Okay? Thank you.